Beginning. Okay, hi, I'm Barry Potter, and this is my microbial fuel cell presentation. I'm going to talk to you from behind the camera because it's probably a little bit hard to hear me right now. So let's zoom in a little bit. Zoom in on the smartboard. And rickety old tripod. Okay. Crooked, rickety old tripod. Okay, so here's a problem scenario 4C. It's my microbial fuel cell. Now, the first, when I was brainstorming, the first thing that I was thinking about was using bell jars, the kind that's commercially available from Food Line or your local grocery store, and using that. The problem that when I started doing the research was I didn't think I'd get enough electricity out of it to be very measurable. So, I wanted to use something a little bit bigger. So, what I decided to do was use this fish tank that I have. I have this fish tank that was donated to me, and I never used it. I was going to get a lizard or something, but I decided not to. And I thought maybe I would take a piece of plexiglass and split the anode and the cathode chambers, but that didn't work too well. It didn't seem like it was going to work too well. It seemed like there's going to be a lot of gluing, and I was worried about the integrity of it. So what I thought I was going to do is get another fish tank and use two of them together, one for the anode and one for the cathode. But I could not find another acrylic fish tank. All I could find were glass ones, and cutting holes in glass just didn't seem like that was going to work too well. So what I eventually did was I decided to use a piece of PVC pipe, and let's see, zoom in if you can see this a little bit better. A piece of PVC pipe for the anode chamber, and immerse that in the fish tank for the cathode chamber, and have the anode inside that PVC pipe, have it sealed with the PM on one side, and then have the cathode, the fish tank, just be the cathode with the cathode, the carbon fiber cloth is the cathode on the outside, and it seemed like a really good idea. The problem was that I came up when I was trying to find is I couldn't find commercially available 6-inch PVC pipe. I could only find 4-inch. So what I ended up using was two anode chambers out of 4-inch PVC pipe. So this is 4-inch PVC pipe. So I have two anode chambers inside that fish tank, and seem to work okay. I'll show you how that worked. So I started building it. So here's my list of materials: PVC pipe, end caps, reducers, glue, the aquarium, wire, solder flux, and I'll show you why I need the solder here in a minute. Carbon fiber cloth. I didn't use all the carbon fiber cloth that I wanted to, or that I had ordered. I still have one big piece of it. I don't know what I'm going to do with it, but maybe I'll make another one. Conductive glue, bought at Radio Shack, $5, and then benthic mud and river water. Okay, and then of course the nutrient agar solution. So the next thing we do is let's prepare the nutrient agar solution. So here's me preparing here's the nutrient agar solution. These are the end caps, the PVC end caps. They're going to be glued onto the end of the anodes, poured it in there, let it refrigerate overnight. Seemed to work okay until I went to put it together, but I'll show you that in a minute. Here's the wire. Now the wire was stranded wire. I wanted solid core wire. I couldn't find it unless it was like a 100-foot roll. So I live in a small town, so I had stranded wire, and I just put some solder on it because the way I did it was I would weave the wire in between the cloth and then put glue on it and this was made it a lot easier to weave it. If I put some solder on it, made it a little bit more solid. So that worked out well. And then testing the continuity of the carbon fiber cloth. Now this carbon fiber cloth I bought on eBay. It was cheap. It was $7 a sheet or something. So I wanted to make sure is this really carbon fiber cloth? Does it really work? So I tested the continuity of it. So put the digital multimeter on it, made sure that I got zero resistance, which means it was a good conductor, and that worked out well. So and here's a picture. That's the end cap that I drilled a hole in and ran the wire through. And you'll see here, right here, is one of the anodes, right here, with the wire stranded through there and glued on. And of course, here's the mud samples, the benthic mud, and the water. I had a bit of trouble getting really good mud samples. The rivers around here are mostly rocks and red clay, and there's not a whole lot of this stuff, so I had to kind of go off to the side where there was a lot of leaves and twigs and stuff, and so it wasn't real clean, but I got it as clean as much as I could of this stuff, and well, it seemed to work. I wish I'd have had better quality mud. Here's me assembling the anode. You can't see it very well, but the anode itself, the carbon fiber cloth, is in there, and I packed the mud around there, made sure that it didn't touch anything, that the whole thing was covered with mud, and then glued the end cap on and glued the PEM cap on the other end of it. Now the problem when I went to put it in the fish tank was that the PEM stuff started to fall out. So what I had to do was I had to cap it. The first one I put a plastic cup on there, and it kind of worked, but I didn't really like it that well. And I saw this laying around, so I took it and I drilled a bunch of holes in the end of it. It's a measuring cup. I don't know, I guess it's 1 cup, and drilled some holes in it, and that kept the PEM in this end. You'll see this end is just a reducer, and it just, that whole hunk of that stuff wanted to fall out. I didn't have any kind of screen or anything to keep it from falling out. So, and there it is. There's the Muddernator. You'll see right here, I just made a little wooden block, and I put a light bulb on there to see if it would light the light bulb, but it never did. These are my anode. The white is my anode lines. The black is my cathode lines. You see I have 2 going to each one. 2 anodes, 2 cathodes. I made sure when I cut it was approximately about the same square, same surface area. So I had about 34 square inches on each. So on each, 34 total square inches for the anodes and 34 total square inches for the cathodes. And this is just just the pump that I ran just to aerate it, keep the water aerated. And then so we started data collection, right? And there's me taking readings. I got readings right away. I got about 89 volts after just a couple hours of it running, and it steadily went up. And I'll show you the graph of the readings. And there's the graph of it. Today, it's running about 495 millivolts. When I started, it was 89, and it kept steadily coming up. It got to about 400 and kind of leveled off for a little bit, and then it's slowly going up. I think if I had more time, maybe a couple more weeks. Let's see, back off a little bit. Let you see that a little bit better. It might go up some. I'm going to leave it running and see what happens. I'm not going to shut it off. But took readings twice a day. There was a couple days where I could only take readings once a day. I couldn't get in the building to take the readings. I have it sitting here in my classroom because of logistics of having this thing around. And so let me show you. Let me turn the lights on and I'll show it to you. Okay, here we go. Careful, you're going to get dizzy here for a second. I have to take this off the tripod. Okay, so here it is. Here's the Muddernator. Here's the filter showing it, aerating it. You'll see the caps. Here's that one cap that I put on there. Didn't work too well. A lot of mud and stuff coming out of it, but still got some electricity. Here's my little terminal block where I measure. Take these off here. I tried to get to light an LED, but it just didn't work. Certainly won't light that light bulb. There's the end caps. You can kind of see the ends where the lines come out, and if I can see, you can see here's the cathodes on the back of the fish tank, and top. So and it seems I was pretty pleased with the way it worked. I wish like I said, I wish I had more time, but we'll see now. I mean, I'm still, and it's still running. It's not running anything now. Let's see. Yeah, see, I'm still getting 495. 495. So I think if it runs, I mean, it's been at 495 since about late this afternoon. So it may be peaked out at about 500 millivolts. But yeah, it's working. Muddernator. Remember that.